Next, we discuss about doubly reinforced sections at the ultimate limit state. In one of the previous videos, we have discussed about the K value equals to 0.167. The value sets a boundary for a singly reinforced or a doubly reinforced section. For a singly reinforced sections, the value K will be less than or equals to 0.167. For a doubly reinforced sections, the K value will be more than 0.167. We also mentioned that the singly reinforced sections will only require the tension reinforcement bar. The compression reinforcement bar is not required. However, for a doubly reinforced sections, the compression reinforcement bar is required. The area of the compressive reinforcement bar is represented by the symbol A'(S). Because of the compressive reinforcement bar, the stress plot diagram and the strain diagram will vary slightly from the singly reinforced section. The centroid of the area of the compressive steel bar is determined by the D' as measured from the top of the section. The strain diagram will be identical to a singly reinforced section, except you will have reinforcement bar here and the respective strength is represented by epsilon SC as determined through interpolations of the linear relationship between the limits of the compressive and the tension strength of the concrete and the steel respectively. The stress plot diagram is also similar to the singly reinforced section, except that there is an additional compressive strength of the reinforced concrete embedded in the compressive region. To ensure the tension steel bar to yield at the ultimate limit state, the X is limited to be 0.45 times the depth of the section. The height of the stress plot is defined by 0.8 times the height of the neutral axis. The maximum compressive stress of the concrete is determined by the design strength of the concrete. The lever arm will be determined by the lever arm distance between the compressive concrete and the tension steel. As there is a compressive reinforcement bar, the lever arm it will be equals to 0.82 D. From the stress plot diagram here, we will determine the equations based on the equilibrium equation. In the case that sigma Fx is equals to 0, the tensile force in the steel bar will be equals to the summations of the compressive force in the steel and the concrete, as represented by this equation. Assuming both the steel bar in compression and tension yield at the same time, and the concrete is at its limit together with the yielding of the reinforcement bar, the equations are given here. The equations for the tensions and compression steel will be the same, except one in tensions, another in compressions, and the amount of reinforcement bar provided may be different. Taking the positions of the neutral axis equals to 0.45 D, you will obtain the S and substitute into the equations for the compressive concrete. The whole thing is to be multiplied with the lever arm equals to 0.82d in order to obtain the moment acting within the section. Reorganize the equations, you will obtain this equation. AS here represents the area of reinforcement in the tension steel, and AS here represents the reinforcement area in the compression steel. Next, we need to determine the area of reinforcement bar in the compression steel. It is determined based on the equations for the moment within the sections. The moment here is determined by the summations of the moment due to the concrete and also the compression steel. It is obtained by multiplying the FCC with the lever arm Z and also FSC with the lever arm from the FSC to FST. The distance here is determined by minusing the depth with the d'. Substituting the relevant value into the equations, reorganize it, you will be able to obtain the equations for the AS'. These equations can also be expressed in the functions of factor K. Either equations will do. Once you have determined the amount of reinforcement bar in the compression steel, substitute the relevant value into the equations that were generated previously. From there, you will be able to determine the amount of reinforcement bar required in tension steel.